Greetings to all in Dr. Abha Chemistry Pathshala. So today we are going to talk about types of chemical reactions, and let's get started with the video. So the different type of chemical reactions which we generally study in organic chemistry are substitution, elimination, addition, molecular rearrangement, oxidation and reduction. There are a few other specific reactions also, but I will only be covering the general reactions of substitution, elimination and addition. So we are going to talk about only these three. Okay, now if you look at organic as such, I think entire organic can be studied under three flags: substitution, addition and elimination. It becomes very easy for students to analyze how organic reactions mechanism would proceed if the child is able to understand what type of reaction is it. So there are certain tips and tricks which help you to understand the nature of the reaction, the type of the reaction, right? So let us first start with the substitution reaction. Substitution reaction is quite similar to what you talk, in terms of displacement reactions of the inorganic chemistry. So what we talk here in substitution reactions of organic is, the easy way to identify is, here an atom or a group of atom will be replaced by another atom, right, or group of atoms. For example, the most common functional groups that show substitution reactions are alcohols, halides. In fact, we do alkanes also undergo substitution reactions. Now, how to understand whether there is a substitution reaction which is undergone? See, that's very simple. If you look at the first reaction, ROH in presence of SOCl2 gives you RCl-SO2 plus HCl. Now what is happening is, OH, that is the alcoholic functional group, is being replaced by halogen. So that's a kind of substitution reaction. The number of bonds remains the same. One bond broken, one bond made. So thermodynamically, not much of a difference. A single bond broken, a single bond has been created, right? So if you look at the second example, RCl, that is the halogen, undergoing substitution reaction in presence of sodium ethoxide to give you ether and a byproduct NaCl. In a substitution reaction, you will always land up with certain byproducts, right? Because the atom has to be displaced by the reactive species, by the substrate. Third is alkane. Kids, just be aware of it that alkanes, it is not easy for the alkanes to undergo reactions. Why? Because carbon and hydrogen single bond is very, very strong. We need quite a high amount of energy for the breakdown of this bond. So it's not easy for alkanes to undergo reactions, right? So what we make alkanes undergo free radical, that is under very high temperature and pressure, they undergo substitution reaction. And if you look at this, we have taken chlorine in presence of HNu, and what we get is alkyl halide, and the byproduct is HCl. There is a difference between the first substitution reaction and the third substitution reaction. We will just be talking about the types little later. Okay, so there is one more substitution reaction. We can see here the fourth one, benzene. Benzene has, if you can make out, benzene has got 3 double bonds. Benzene has 3 double bonds, and most of it, we feel that it should show addition reaction because of the presence of 3 bonds. But it doesn't show addition very easily. Instead, it shows substitution reaction. Now just see, chlorine, it has one hydrogen. This hydrogen has been replaced by Cl as an electrophile, and what you get is chlorobenzene with a byproduct. Now above reactions we can categorize. We can categorize the above reactions under different headers, right? So let's get started with the types of the substitution reaction. I will not be going into the details of the mechanism. For that you can look into the separate videos. Only this is about the how we recognize the types of substitution reactions, right, depending upon the nature of the attacking reagent. So first let's talk about nucleophilic substitution reaction. We represent them as SN also, and then we further have types also: nucleophilic substitution reaction 1, bimolecular, unimolecular, right? We will be talking about them in the separate video. Here we just want to take a stock of all the types of reactions which are present in organic, right? Okay, so if you look at the function groups that generally undergo nucleophilic substitution reactions are alcohols, halides. Okay, acids also undergo substitution reactions. The OH of the acidic group, that shows nucleophilic substitution under the similar conditions as alcohols do, right? So OH will be replaced by another nucleophile, Cl will be replaced by another nucleophile, right? And let's move on to the next category, benzene. As I told you before, that benzene has double bonds. It has got 3 double bonds. Despite of that, it doesn't show addition reaction because the double bonds are in conjugation, right? So it's very stable and it resists addition reactions. So what does it show? It shows substitution. Now what is the attacking reagent? In the benzene, the hydrogen atoms are replaced by the electrophile. The hydrogen atoms, they are replaced, they are removed as H plus, and the attacking reagent is electrophile. For performing the reaction, we will need certain electrophile generator, which we will be doing in the separate video about the mechanism of the electrophilic substitution. Okay, free radical substitution. Now first of all, free radical requires very stringent conditions of high temperature, pressure, right, or sunlight. Now generally free radical reactions are performed for the species which do not undergo substitution easily. As I mentioned before, alkanes, the carbon and the hydrogen bond is very strong. So for the alkanes, the only possible reaction that happens very easily compared to the other types, right? So that is the substitution reaction. So we make free radical substitution for alkanes, free radical halogenation, we do nitration also. So halogen can be substituted, nitro group can be substituted in alkanes via free radical mechanism. So I have given you an example of a nucleophilic substitution. I have given you an example of a nucleophilic substitution, electrophilic substitution and free radical substitution, right? Okay, so let's move on to the second category, that is the elimination reaction. Now if you look at the flow chart, this is the second, so elimination reaction. Now what are elimination reaction? How to identify elimination reaction? Elimination reaction can be something like a group of the atoms are removed from the organic compound. It is not that easy, because the way to identify an elimination reaction will be always understand the single bond will be broken, right, and you will land up with the multiple bonds. Thermodynamically, that's not as energetically feasible process. A strong bond broken and the weaker bonds being formed, a strong single bond being broken and the weaker bond, a multiple bond being formed, that is an additional pi bond, which is a weaker bond being formed, energetically not a very viable way. Still it happens, right? Why? Because we use high temperature and we use catalysts. Sometimes we use specific reagents like alcoholic KOH, right? So, and very easy way to identify will be, as I said, in the product side, the number of bonds will increase, the unsaturation will increase. We will start with saturated compounds and we'll land up with unsaturated compounds, right? Okay, now this kind of reaction, the unsaturated system, that is the alkenes, alkynes, will find it very difficult to undergo this reaction. They will not undergo elimination reaction. So let us work out on the kind of the functional group that will show this kind of reaction. Let's work it out. Okay, so if you look here, I have taken the first reaction which I have taken. The first reaction which I have taken is a reaction of alkyl halide, right? So now what is happening? This alkyl halide, if you can see, there is a carbon and halogen single bond. There is a carbon and halogen single bond in presence of alcoholic KOH. Students, I want to draw your attention towards a difference between alcoholic KOH and aqueous KOH. Alcoholic KOH and aqueous KOH, there is a lot of difference between them. I will be talking about the difference in a separate video, but please do mention the medium while you are using KOH, right? So you take alcoholic KOH and elimination reaction takes place. This Cl will be removed. This Cl will be removed, and from the beta position hydrogens will be removed, and you will end up on an alkene with KCl and H2O as the byproduct, right? And the removal is very simple because both the positions are very similar, but you could land up with unsymmetrical halides, and then we will be following some rules, right? Okay, and look at other elimination reaction. If you look the second one, alcohol, right? So alcohol also undergoes elimination under the presence of conc H2SO4 and very high temperature 443. Why do we require high temperature? Because we need to break the bonds. We need to break the single bond so as to make a multiple bond. So we need high temperature and pressure. Always students, please ensure, just look at the arrow, and always the arrow will be supported by certain conditions whenever we are looking for an elimination reaction, right? So OH is removed and we land up with a double bond. That is, it is a kind of an elimination reaction. Always we will have byproducts. Always we will have byproducts, right? Here water is the byproduct. And if you look at the third reaction, I have taken a vicinal dihalide, that is 1,2-dichloropropane. Now 1,2-dichloropropane in presence of NaNH2 and liquid ammonia, very strong base. A very strong base will give you the formation of the triple bond with NaCl and ammonia as the byproducts. Let me draw your attention that the same reaction can also be performed in two steps. In the first step you use alcoholic KOH, and the second step you use sodamide, right? But we can always perform this in a single step by using a stronger base like NaNH2 in liquid ammonia. So this is again a case of elimination reaction, right? Okay, now I have given you a hint, although we will be talking about this later, that is, there are rules where elimination is performed. We follow certain rules, especially for the unsymmetrical halides, right? So which beta to be removed? For that we will be studying Sedzev rule and Hoffman rule to be covered in the different video, right? Hoffman is just the opposite of Sedzev. So Sedzev rule, if you remember, we have to go for the more alkylated alkenes during the dehydrohalogenation of alkyl halide. So we'll be talking about it in the different video. Okay, so the third basic type of reaction is the addition reaction, something which you call at combination reaction in your previous junior classes. So in organic chemistry, addition reactions are reactions which are generally performed on unsaturated compound. Wherever you see carbon double bond, carbon triple bond, carbon nitrogen triple bond, carbon oxygen double bond, right? All these, wherever the carbon is showing any kind of multiple bond, right? This reaction will be possible, right? So let's work out on the different types of the addition reaction, right? So I have just put certain groups which will be showing addition reaction, and most important it is with alkenes, alkynes. Yeah, okay. So let's get started. How to identify whether the given compound is undergoing an addition reaction. you will always see that the multiple bonds are converting into the single bonds. You will start with ethyne and you will land up with ethane. When you add hydrogen to it, when you add chlorine, chlorine, you will get other addition products. But from their multiple bonds, you will land up on the single bonds, right? And usually the reaction will not require very stringent conditions like high temperature, high pressure, free, sunlight. No, this will take place at very, very normal conditions, because thermodynamically, if you look at it, from a multiple bond, two pi bonds, two weaker bonds broken, and we are going to a stronger bond, or one double bond broken and we are going to a two single bonds, two double bond broken, that is a triple bond broken, and we are going for 4 single bonds. So thermodynamically it is a very, very viable way. So generally you will see that there are no stringent conditions, no high temperatures, right, required. And the solvent which are required we don't require very highly polar solvents, most of it, right, most of it, all the exceptions will always prevail, right. So like alkenes and alkynes, they undergo addition in inert solvent, right. So those kind of conditions will be there. Let's move on to their types. So there are primarily three types of addition reactions. So the first is electrophilic addition, where the rate determining step will be addition of the electrophile. Nucleophilic, where the rate determining step will be the addition of nucleophile. Free radical, rate determining step will be the addition of the free radical. Now guys, I'll give you a very simple example. Okay, electrophilic addition generally takes place in unsaturated hydrocarbons, alkenes and alkynes. Nucleophilic addition will always take place where carbon has is attached to a heteropolar species like oxygen, nitrogen, etc., multiple bonded, right? And free radical addition, usually addition, they do not require strong condition, as I mentioned, but there are certain compounds which do not like to undergo addition. Can you guess something? Yes, something like benzene. They do not undergo addition very easily. They undergo substitution easily. So such compounds will be, you will always see that for their addition we require free radicals, right? And also we have a specific alkene addition, free radical mechanism, which I'll be just talking about while giving you an example, right? So now if you look at here, guys, see, if you look at this alkene, right, and the addition is of chlorine. Now you will see that the chlorine is a homonuclear system, right? But in this homonuclear system also, I'll be talking this in mechanism. When this chlorine is brought closer to the alkynes, what happens? It develops charges, right? And the first step will be the addition of the electrophile, and then the carbocation is generated, and we'll talk about it in a separate video, right? So addition of chlorine across the double bond will be the rate determining step. So we call it electrophilic addition. Like if I take something like HBr, this has got a electrophilic part also, and it has got a nucleophilic part also. Br will have a nucleophilic part, and H plus will have an electrophilic part. Still, students, the addition of the electrophile will be the rate determining step, and the reaction will be named after it. Please mind it, in alkenes and alkynes, in fact all the addition reactions, we have electrophile and the nucleophile both getting added across the multiple bonds, but the reaction is only named after the attacking reagent which is attacked in the rate determining step, right? So in this, let me draw your attention. In this, we are following Markovnikov addition. You can look into separate video, right, for Markovnikov addition. Okay, so let's move on to the next reaction. Okay, so generally you will see in alkenes and alkynes they undergo electrophilic addition reaction, and there is a free radical addition on alkenes and alkynes, which we call as, when we do not follow Markovnikov, that will only happen with HBr in presence of peroxide, right? So you can go for a separate video to find out why only HBr undergoes addition, why not the anti-Markovnikov addition, why not HCl, why not HI, right? So this is a kind of free radical addition which we take as Markovnikov addition. Okay, now let's move on to the another type of free radical, benzene. As I said, benzene resists addition reaction. Why it resists addition reaction? Because we know its aromaticity will be lost. The 3 double bonds which it has, they will be broken. Sooner or later they will be broken as it starts undergoing addition reaction. And breaking of the double bonds means loss of the aromaticity. From the stability to the instability, which benzene will like to resist. So we make it undergo addition reaction with the very strong conditions like sunlight, high temperature, pressure, right? So this is an example of free radical addition which is undergone by benzene rings. Like, okay, so let's move on to the next type of addition, that is nucleophilic addition. Nucleophilic addition will be undergone by species like one I have shown, right? Something, you know, what is happening in this is, if you look here, O gets a partial negative charge, C gets a partial positive charge, and in HCN there is a nucleophilic center and there is an electrophilic center. So the first step is, that is the rate determining step, is this CN. This CN, that is the nucleophile, gets attacked, it attacks on the electrophilic center, that is carbon. So in the first step CN gets added, in the second step hydrogen gets added. Finally the addition product will have the nucleophile as well as the electrophile, but still we name it as nucleophilic addition because it is the rate determining step that matters at the end of the day. So I have tried to you know, pick up all the types of major types of reactions, that is addition, elimination and substitution. So whenever you look at a reaction in organic chemistry, before you jump onto any conclusion, do find out what type of reaction is it, or if you have to make a compound undergo a reaction, do find out. Like for example, if you halide is given to you, definitely halide will undergo substitution, halide will undergo elimination, right? These are the, if you have an alcohol, will undergo substitution, will undergo elimination, dehydration, right? So always, you know, these kind of mechanisms, these kind of tips will facilitate your study of the organic compound, and these are very, very basic reactions, and there is you know, there are no you know, big rules which you have to follow, right? So that was it for this video, and hope this was some value addition to you, and for the next video, see you soon. God bless, stay blessed.